deductive or inductive reasoning? We good? So if we start from specific cases by observation and come to a certain conclusion, what is that? I cannot hear you. It's inductive reasoning. Thank you, Hannah. Okay. If we already have the theorem or we have already the conclusion, and you want to prove it. So from general to specific, what is it? Excellent. That's deductive reasoning. And we also talked about counterexample in which one? Inductive or deductive? In inductive, because it's specific case, right? And you know how to find the counterexample, right? So your assumption has to be true, but your conclusion has to be wrong. Then you can say, oh, this statement is wrong because of this counterexample, right? Okay, that's good. So we can now move to chapter 1, section 2. Are you ready for that? Yeah? How come your voice is... Let's do it. Yeah, thank you. I love you. That's what I need, especially on Friday, right? Yeah. Come on, guys. This is my last class for today. Woohoo. After this, I can take a nap. How nice. Okay, I don't know about you. If you have another class. Sorry about that. Too bad for you, but I'm okay. Okay, so second section, we're going to do estimation. Oh, I think you guys are very excited now about estimation. Okay, so why do you do estimation? When do you do estimation? Right. I don't carry my calculator all the time. Even if I have my cell phone and has really nice app here for calculator, sometimes I get embarrassed if I just take it out and calculate everything. So we do estimating a lot of times. Estimation, does it need to be exact number, accurate number? No, it has to be just close enough to the right answer. But it has to be close, right? If you have wrong estimation, you're gonna be in trouble, right? Okay, so we're gonna do the estimation today. Here are some examples of estimation. Let's look at this example. Sonia decides to purchase cupcakes for a party. Can you estimate her cost? Because she purchases 19 cupcakes at $1.95 each. So for this case, let's suppose she's a committee member for a certain group and she needs to have the budget. If she lower her budget too much from what she needs to spend, she's not gonna have enough money, right? So she cannot spend money accurately. So we need to help her estimating the number for that. Right? Are you ready to help her? Yes. So how would you help her to estimate it? Let's suppose she doesn't have any calculator or pen or pencil, so she needs to give the estimation right now.
Just round it to $2.
That's what we just did, right, in another class.
Yeah.
Yeah, so we can just round it. So let's make it easier number. 19 times something is kind of hard for me. I don't know about you, maybe you have better calculation skill than I have, but 19 is not a good number for me. So I'm gonna change that to 20. Oh, that's so much easier. Thank you. How about 195? Oh no. $2. I like them more. So 20 cupcakes, about $2 each. So $40 is what you need. I think that's really good estimation. You think so? But did we overestimate or underestimate? We overestimate that. So just keep that in mind. Okay? The overestimating is for this case, this context, I think a little bit better. Don't you think? Yeah, so depending on what context you have. Okay, so that's really good. How about this one? At a local discount retail store, Christy purchased a rug for $15.89, toothpaste for $1.49, diapers for $19.77, shampoo for $4.93, dog food for $12.88, and candy for 80 cents. The cashier said the total bill was $69.51. The big mistake we do, we just give the money or credit card, right, without checking it. But let's check if it is right or not, okay? Can you estimate to determine this amount is reasonable? Does anybody have any strategy to estimate the total bill? That's round. Okay, I like that. So 1589. Let's make it to easier number. What?
16.
16. Keep that in mind. And 149. About $1.50. So together we have 1750. 20. So 3750. 5. 4250. 13. 5550. About 1. 5650. No, ooh, they charged us too much. So no. If you didn't check that by estimating, you're gonna be overcharged. That's why you don't want it, right? Okay, so that was really good estimation. Right, good job. Okay, so here are two things that Christy thought about. Okay, she first thought about nearest in 10 cents. And then she thought about nearest in dollar. We kind of mixed it, right? Because this we did 16, 20, but this one we did 150 instead of $1, right? So if we go consistently with either 10 cents or nearest dollar, well, our answer is similar, but we can be more consistent. So if you compare these two, there's a little bit of a difference. Which one do you think is closer to the actual value? Nearest dollar or nearest 10 cents? That's right? If we go closer to the smaller digit to the right in the number, right, place value, we go closer to the actual value. Okay? A little bit more complicating with this one though, but it was more precise. Okay, good job. Okay, here's another one. The number of bushels of grapes produced at a vineyard are 71,309 Cabernet Sauvignon. 123,000. I don't know about champagne or wine, so if I'm wrong with the pronunciation, just ignore that, okay? You don't have to correct me because I will not remember that again. Okay, 123,879 French Concord, 106,490 Chenin Blanc, 5,960 Chardonnay, and 12,104 Chardonnay. Whatever. We got these. We got these wines and we got the number of bushels for each. Select the best estimate of the total number of bushels produced by the vineyard. And I want to use your own idea to solve this. So you guys need to help me. Right? Tell me, what can I do? How would you round this? Can you see the numbers? Okay, so 71,309. I don't like that number. Too complicated. Can you make it simpler? 70? 1,000? Okay, so looks like we are rounding. Oopsie. So it sounds like we are rounding nearest to what? 1,000. Okay, 71,000, and let's be continuously rounding nearest 123 or 4,000. Thank you. So when you're rounding nearest 1,000, our counting here should be something thousand, something thousand, something thousand, right? So there's nothing in the hundreds, tens, or ones. Are we good? So when you are rounding, if you are looking at the next digit, if it is greater than 5 or greater than or equal to 5, you need to round that up, right? So instead of putting 71,000, let's suppose we have a number like 71,609 instead of 309. We are looking at, I'm going to underline 1,000, and then I'm going to look at the next digit, because it's greater than or equal to 5, we need to round that up, and that's approximately 72,000, right? With our number here, 71,309. We are rounding nearest 1,000, but we are looking at the next digit, which is less than 5, so you drop it, right? So that's approximately 71,000. Okay, are we good? Okay, so we have 71,000, about 171,000, about 124,000. And how about this one? Chenin Blanc. 106,000, because 400 is less than 500, you drop it. 1,000. How about this one? 5,900, 6,000? Thank you. Because look, 5,960, we need to round the nearest 1,000. The next digit, 9, is too big, so we need to round that up. Okay, it's about 6,000. Excellent. How about this one? 12,104. 12,000. So 12,000. And make sure you line up the place values there. Now we can add them together. We know this is going to be something 1,000, right? Maybe some of this, I think you can just calculate in your head. So let's take a look at this. This makes 10 and 9, so 19. Thank you. And you can write that right above here, because that's not just 19, not 10, but it's 10,000, right? It goes up here. And we have altogether 11 10,000. So we have another one carrying up here, and we have 3. So we have 319,000 push-ups, right? Okay. That is very close to what? C, 300,000. This is when we rounded nearest 1,000. We can also round it even easier number. How about if we round this to 10,000? Can we do that? 10,000. Okay, then what's changing here? 71,309 will be 70,000. How about this one? 123,000. 120,000, right? You're gonna have something 10,000, something 10,000, something 10,000. So let me look at that again, because I think some of you are confused with it. Take a look at this. 10,000 is this one. Ones, tens, hundred, thousands, and 10,000 is this one. So look at the next digit. Less than 5. So drop it. It becomes 120,000. Good? Okay. How about this one? 106,490. 110,000. Let's take a look at that one more time. This is the last time I'm gonna just look at that, okay, together. So this is your number, and we are rounding nearest to 10,000, which is this one, right? You can look at the next digit greater than 5, so you need to round it up, so it becomes 11. 10,000, which is 110,000. Okay? Okay. How about next one? This one. What? 10,000. So that's a little bit confusing, right? So let's look at that number together too. So 5,960. Where is the 10,000? Yeah, this is ones, tens, hundreds, thousands. So 10,000 is here. There's nothing. But still, you're gonna look at the next digit. 5. Equal to 5 or greater than 5, so you need to round that up. So it becomes 10,000. Right? Last one. 12,104. 10,000 again. Right? So if you add them together, what 10,000 do we have? 7, 2, 9, 10, 12. Round it up, yeah. Carry it over 3. So it's gonna be about 320,000. Or you can round the nearest 1,000 and say that 319,000. Which one is more precise? Left-hand side, right? So this one may be easier for you to calculate, but it's closer to the actual answer. So you can, round it differently, but you can approximate that. Okay? Any questions so far? Are we good? Okay. Okay, here's another example that we can do. I have lots of examples for you. Okay? The Martellus, and most of the examples are real world situation. I think that's actually better than just calculating with numbers only, because we need to know how to apply the math. We always ask, how do we do math? Right? We want to use it. So I'm gonna give you some examples like that. Okay. The Martello traveled 1,276 miles from their home in Springfield, Missouri to Yellowstone National Park. If their trip took 19.9 hours of driving time, estimate the average speed in miles per hour that their car traveled. If their car used 52 gallons of gasoline, estimate da 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 da. We have three different questions here. So how about we make some groups? Okay. We have 1, 2, 3, 4, 5 rows of tables. No, 6? 5, right? From here it's really confusing. Okay, how about first row, you guys solve this one. So we go like first row, second row, third row, fourth row and fifth row. You got that? So first and fourth, you solve this one. Second and fifth, you solve this one. Third row, you rock. You're gonna only solve this one, okay? Go ahead. Once you are done, you can talk with your neighbor about it, how to solve it. And then you still have time to solve the rest of the problem. Everybody needs to work on this. I can randomly call your name for this, okay? And Lisa, I want you to find answer for C. Okay? I will give you only 1 minute.
Yes.
Show me your thumb if you will solve this. Show me your thumb if you will solve this.
I just don't. I rounded the
Anybody?
miles up to 1,300 hours.
Second row, you guys.
I divide, I just figure out if you usually do 130 divided by 2.
Zachary, did you find it?
Yes.
You need to show me your thumb. If you have any. Thank you. Okay. Awesome. I think most of you got that. Great job, guys. And first group. So let me read this question one more time for everybody. If their trip, even if you didn't solve this one, you need to try to solve it, okay? So think about how you can solve it. If their trips, oh well, hold on. So they traveled 12,000, no, not 12,000, 1,276 miles total, right? From their home to National Park, Yellowstone. If their trip took 19.9 hours of driving time, you need to estimate the average speed. That's the question one, which is miles per hour, right? And the second question is asking, if your car uses 52 gallons of Guess. Estimate the average gas mileage. So average gas mileage. Okay, so that's miles per gallon. And see if the cost of a gasoline average $3.99 per gallon, $3.99 per gallon, you need to figure out the total cost of the gasoline. So total cost. Okay, that's a real world situation we can face almost every summer, right? So let's try to solve this together. Okay, group one. Tell me how you guys found the answer. Anybody? Group 1 or 4? How about you introduce yourself, just name, so we can get to know you.
Oh, I'm Cole. So what I did is I rounded the 1,276 miles up to 1,300.
So 1,276 miles near, and you rounded to?
1,300.
Okay, very good. And then?
I rounded the speed from 19.9 to 20.
So not speed, the
the
time.
hour, sorry.
Okay, so you changed it 19.92 nearest what? 20? So that's really good number that we can calculate. I mean, mentally we can calculate that. But we need to know the speed, right? So how do we find the speed?
I took the amount of miles divided by the time.
Exactly, very good job. Because look, it's mile per hour. Mile divided by hour, right? And we are given the miles. So this was the miles, and that's the hours, right? We can find the speed as mile per hour, right? So what did you get?
75.
75? Thank you. 75 mile per hour is the speed. What do you think?
I got 65.
I got 65.
Oh, then, okay. But you got the same calculation here? Okay, maybe it's 65. It's okay. Okay, I just need to know what it is. Okay. So using the same procedure, you can find the right answer. Let's see. Yeah, 2 times 6 is 12, it's 65. Okay. All right, now, part B. We have 52 gallons, and the gas mileage is what you need to find with the same mileage there. Group 2 or 5? Anybody?
I just
Your name?
Riley.
Riley?
I rounded the 1,276 to 1,200.
Oh, 1,200. Why 1,200?
It just seemed closer.
Okay.
But it is the easier number, and then I rounded the 52 gallons to 50.
To 50. So you round down both of the numbers. Okay. And divided by 50. Why? This was miles, and that's the gallon. Because gas mileage, look, gas mileage is mile per gas. So per 1 gallon of gas, how many miles can you go? That's gas mileage, right? So yes, we're gonna do miles divided by gallon. If you do that way, what do you get? 24 miles per gas. Maybe some of you had a different answer because your rounding could be different. That's okay, right? So is there anybody who rounded it differently? And name?
I'm Camden.
Camden. Okay.
I rounded 1,276 up to 1,300,
1,300.
and I got 26.
Oh, you did a 50
Oh.
gallon?
Yeah.
Okay. Then you get
And then I got 26.
miles per gallon. Which one's closer to the actual number, do you think? 26 or 24? 26. And our number here, the mile, is in between these two, right? Right? So it could be in between 24 miles and 26 miles, but a little closer to 26 miles per gallon. We can think about that too, right? Okay, good Any other idea? No? Okay, then let's go to C. So the gas price is $3.99 per gallon. Wow, that's expensive. How much is the total cost?
I'm Audrey. I rounded the 52 gallons down to 50, and then I times it by 4, so I rounded the 3.99 up.
Hold on, let me write that. So 52 gallons is approximately 50 gallons, and then
And then the 3.99 I rounded up to 4,
to $4.
and then I times 50 by 4 and got 200.
What do you think, guys? Is it equal to 20? What's the unit here? 20 what? Dollars.
200.
200. Thank you. About $200. Okay. Any other idea? Very good. You guys saw the same way in the back row? Okay. Oh, excellent. Okay. So yeah, I like that estimation. I wouldn't do it differently because I think that's $3.99 is very close to 4. And 52 is very close to 50. So we know that since we round this up, that's round down, we kind of compensated each other, right? So one goes up, one goes down. So I think that's very close to the actual answer. Very good. Okay. Any comments? No? Good? Okay. Nice. Okay, here's one more example for estimating. Before this era of GPS, like me, your parents maybe used to map a lot of times. Nowadays, kids don't know how to read the map. I mean, some do, but most of us don't. Because we don't have to. GPS tells you which way to go and how long it takes, da 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 da. But in my time, we had to use the map and we had to calculate how long it will take and how far you have to go to that certain point, things like that. So I'm going to introduce you this 1800 map, okay? In the mid-1800s, thousands of settlers followed the trails to the west to gain cheap, fertile land and a chance to make a fortune. You all know that. This is a history. Oh, so this is a good way for you to integrate the subject, right? When you're doing the history, you can see the map there. Okay, so that's another good way. One of the main trails to the west was Oregon Trail. So the red one here, starting from Missouri, right, went all the way to Oregon. It's Oregon Trail. Okay, which ran from Independence, Missouri to Oregon Territory. Another trail, the California Trail, ran from Fort Hall here to Fort Hall on the Oregon Trail to Sacramento, California. Much shorter. A map of the Oregon Trail and California Trail is shown below here, red or blue. My question, the first question is this. Using this Oregon Trail, can you estimate the distance from Independence, Missouri, to Fort Hall, here, from here to there? Can you estimate the actual distance? How can we find that?
We use the scale.
Aha, that's the key, right? Do you see the scale here? What does it say? This much is about 250 miles. Do you think it's an actual number or it's estimation? It's estimation. We're gonna use our estimation. So it's about, yeah, so about this much, right? That much is 250 miles. So you can use your estimation there and think about how many miles is from Independence, Missouri to Fort Hall. How did you get that? How many 250 did you have? 4? So let's see. Okay, so about this much. Oh, It's exactly about my, what do you call this? The length of your, I don't know, anyways, this was it on 250. So I think about 1, 2, and 3, and 4. But there was like crooked, roads there too, so a little bit more than maybe 4 of my measure here. So we can just do, it's gonna be a little bit more than times 4 or approximately times 4, right? So 250 times 4 miles is 1,000 miles. Okay, excellent. Okay, another question. Using the California Trail rule, estimate the distance from Fort Hall to Sacramento. Can you do the same thing? About how many measure? I think this is a little bit short.
2.5.
2.5? Yeah, I think about 2.5. Okay, about 2.5. What would you say? 200 times 2 is 500, and half of 250? What is it? 125. So add them together. 625. It's about 625. I think that's pretty good. Okay. I think this is the last one we can do. Oh no, now really, this is the last one. So this is the second last one. Okay. Okay, electric bill and utility bill. This is another real world situation that we can face almost every month. Some utility bills contain graphs illustrating the amount of electricity and natural gas used. The following graphs show gas and electric use at the specific residence for a period of 13 months, starting November 2015 and going through November 15. Okay. The last one is the average, colored differently. Okay, so you can see that dark color is actual use, so they don't come and measure actual value every month, but they come every other month to measure actual value, but they estimate, the month, the other month. Okay, so my question first: how often were actual gas and electric readings made? I was looking at this. How often were actual gas and electric readings made? This is gas use, that's electric use. Both of them, you can see that actual estimate, actual estimate, actual estimate, actual estimate, actual estimate, actual estimate. So how often? Every other month, every 2 months. Estimate the number of turns of gas used by not turns, that's the unit. Estimate the number of turns of gas used by the average residential customer in November 15. This is November 15. Can you guess? About what turns, not turns? 60. Yeah, it's about in between 80 and 40, right? So we can say it's about 60 turns, right? Okay, how about this? Estimate the amount of gas used by residents in November 2015. Is that the same?
The second one is the average.
Oh, sorry, second one was the average. So let's look at the average. How about this one then? I would go with the 75 too, because it's right in the middle is 60, and 70 is between that 60 and 80, and it's closer to 80. So 75 I think is better. We already got this one. How about this one? If the cost of a gas is $1.12295 per term, estimate the gas bill in March 15. So we need to find where March 15 is. Which one? This one? Because this is November, December, January, February, March, right? So March 15. How many turns? About 180? You guys agree? Because it's in between 160 and 200. So 180 times 1.12295. You don't want to do that, right? So you want to? Louder?
Round it to
Round the nearest to dollar? Or 1.1? Either way. Okay? If you do that by 1, what do you get? 180. Well, since we underestimated, the actual value should be greater than that. Right? Okay. How about this one? In which month was the most electricity used? July, why? It's hot. You need the air conditioner. Okay. How about this? If the cost of electricity is 8.1716 cents per kilowatt, estimate the cost of electricity in January 2015. Where's the January 2015? This one? Okay, that's January 2015. What would you say about electricity use? Right in between is what? Right in the middle. 1,000? Yeah, 1,000, but it's so much higher than that. 1,100 is about here. I would say this is about 1,200. Because it's very close, right? 12, we can approximate this as 1,200. And how about this one? 8. So 1,200 times 8.
9,600.
What is it?
9,600.
9,600. Thank you. So about 9,600 is the cost. Okay? Any questions so far? So we can use the estimation in a lot of cases. Okay, now if you are given the corn kernels like this, can you estimate the number of corn kernels in this photograph? Does anybody have any idea how to estimate the number of corn kernels?
Put it under within 1 square and then multiply by how many squares there are.
Yeah, I like that idea. That's why I put the grid there too. So you can just say that, oh, I can make, small grids in it and approximately same number of corn kernels are in each grid, in each square. So I can just count about how many there are and I can multiply that by, 5 times 20, right? So let's count, pick any square. How about this one? How many do you see about? This is even hard to read, but we can see about 1, 2, 3, 4, about 20. Yeah, I say about 20. About 20, and I have 20 squares. So there are about 400 corn kernels, maybe more. But about, it's not about, it's okay, right? Okay. So that was another example. How do you feel about the estimation? It's going to be very useful in our real life. What do you think? I know you guys want to finish early. Do you think I'm gonna finish it early? Haha, no. How about we do just one problem solving, then we can finish. Sounds good? Okay. So problem solving is the third section. Okay. And similar to similar to the estimation, problem solving is very useful in our real life because we face the situation that you need to solve every time. So let's take a look at this. Solving mathematical puzzles and real life mathematical problems can be enjoyable. You should work as many exercises in this section as possible. By doing so, you will sample a variety of problem solving techniques. Some of them you will like, some of them maybe too challenging. I don't know. You can approach any problem by using a general procedure developed by George Porya. Have you ever heard of his name? Most of you are freshmen, right? But because you're in education, you're gonna hear about his name, Porya. Porya's strategy for problem solving. It's important. Okay? Okay, we're gonna talk about that too. Let me see if I can pull that. Oh, yeah. So this is Porya's problem solving procedures. Can you guys see this okay? Okay, No, I'm gonna say paper, so, and this is already in your class notes. If you wanna print it out and put it on your, notebook cover, you can do that. So let's just take a look at this for today, and we can have actual problem solving on Monday. How about that? So let's just take a look at this procedure that Korea suggested. And let's see if it makes sense. Okay? The guidelines for problem solving is this. 1, 2, 3, 4 big steps. 1. Understand the problem. You need to know what the problem is, right? You need to know what the problem is asking you to do. And then you're gonna divide the plan to solve the problem. You can think about, I can solve this problem by doing this, right? You're gonna divide the plan. And then you're gonna carry out the plan. And then you have the answer, then you need to check the answer if it makes sense, by plugging back in or using different strategies, things like that. So more in specifically, more in detail for each of these 4 steps, to understand the problem, you can read the problem carefully at least twice. In the first reading, get a general overview of the problem. In the second reading, determine exactly what you are being asked to find and what information the problem provides. Some of the information is important for you to use to solve the problem. Some of the information is useless. You need to determine which is useful and which is not. Try to make a sketch to illustrate the problem, because sometimes the problem is so complicated. If you make it into a picture, it makes more sense to you. It does to me a lot of times. So I change the word problem into either mathematical expression or I draw the picture to illustrate that. You can make a list of the given facts that are pertinent to the problem, right? And determine if the information you are given is sufficient to solve the problem, or if you need more information, you can find it out. When you are devising a plan to solve the problem, you can think about this. Have you seen the problem or similar problems before? Are the procedures you use to solve a similar problem applicable to this new one too? You can also think about, can you express the problem in terms of an algebraic equation using numbers and symbols? You can look for patterns or relationship in the problem. Can you change that problem or simplify it for? Can you substitute smaller or simpler numbers for you to understand it better? Will listing the information in a table help in solving the problem? Can you make an educated guess at the solution? Sometimes if you know an approximate solution, you can work backwards and eventually determine the correct procedure. You can carry out the plan next. So you can use the plan you devised in this step 2 to solve the problem. And then you need to check the result. It's important. You need to think about, does this answer make sense? Is it reasonable? Okay. And you can also think about putting back, the answer to the original question and see if it makes sense. Okay. And you can also think about, is there any different way to solve this problem? You can do that. And so on and so on. Okay, so that's the 4 years problem solving. And that's it for today. Your homework for section 2 is due on Monday. Okay? And if you were not sure